Okay, good afternoon. Yeah, in my session here, I'm going to cover why we think IP quality is important for SoC design and what we've been doing at TSMC to ensure that happen for our customer. And then at the end, probably closing more about what we think that can be standardized in terms of IP quality. Again, as you know, this forum and also this Standards Association been around for some time, previously with Synopsys and now with IEEE-SA. But I think, as I remember, I went there a couple of times, all the discussion for the last 15, 20 years about EDA interoperability, how the tools work together, how different formats are supposed to be compatible. So I like to be the first one to start the discussion on the IP interoperability, and the first topic certainly the IP quality and what aspect of it can be standardized and when other aspect still continue to be developed. So that's the outline of my talk. Why IP quality is important. Our TSMC 9000 program. So the bulk of it in the middle, two bullets: IP quality standard and a summary. Okay. So we already talked about the complexity of the process and the design. So what I have here is kind of a normalized chart of the design manpower, design effort. And it's break up, I think, extra of a bar, we have like 4 color. The grayish one is system verification and architectural design. So those always take a good chunk amount of time there. And like back in 65, it take about 70% of the total. And then last 2 boxes in red, a physical design and IP qualification and sourcing. So that take about 30% of the time. So totally it's 1x, right, for 65 nanometer. As you go down to 40, 28, 20, you can see increase dramatically. So up roughly in 16 nanometer, we're thinking about the effort probably about 5x. Respect to 65 when we talk about all of these activity before you're doing the actual finishing the SoC design. And then totally both the front end and back end will be about 10x more design manpower. So certainly the effort is quite a bit. So if you look at the importance of IP quality, this best way to look at it is from SoC. Going from early days to now 40, 28, and then 16 nanometer. There's probably between 50 to 100 IP using every SoC. A lot of these probably come from different vendors, and you probably have to source and qualify all of these before you want to put it into the SoC. So that's a lot of work, a lot of effort to going on there. And the quality of these IPs are paramount to the SoC. Every one of them fail, then you don't get the chip to work and you have to do a respin. So that's really the chart that shows it's just really a lot of usage of different IP in each SoC, starting way back and now in this time frame here, we talk about 80 or so IP per SoC. So this is another angle to look at the complexity of the process. From 0.13 to 16 nanometers, these are design rules. So you can see is about, if you take 28 for now, it's about 2,000. And then if you go to 16, we got about 3,500 rules, right? So that's quite a lot there. If you look at RC development effort by process node, and it is an effort that we're working with Mentor and on Cadence, Synopsys, and other vendors to really work on the extraction part, because that's really the first step we have to do for every process. Again, from 28 to 16, the effort, which is people and resource we put in time, probably about 8 times more. So that's quite a lot there. DRC deck size, so this is a number of code line in the DRC deck, going from 28, about 40,000, and this is almost 100,000, 95,000. So it's just huge. And again, remember, every IP going through the system, you have to run these things through too, right? DRC deck, you have to run on to check on that. Custom design, complexity, again, this again by effort. 28 is about 2x, and this is about 5x. Quite a lot of work there for custom design. And the other thing too is over time, we accumulate a lot of IPs. This is all the IP that we're managing today, TSMC, 76 IP title. So one standard cell library with 600 cells in there, we count as one title. So this is if you cover foundation IP, analog IP, embedded memory, software IP, interface IP. There's quite a bit, and they cover, 0.135 still have some, all the way to 16, which is you see a little bit sliver on top here in that, and then 10 nanometer. Actually 10 nanometer is just on the horizon. You probably don't see it here. And then software IP is something we add last 2 years, so that's a bunch up here. Majority of the IP you see in the 28 and 20 and 28 and 40. So quite a lot, and how you actually manage all this and ensure the quality of all of it. Because any particular time, any customer could use any one of these, right? So at TSMC, we have a system to ensure the IP quality. So really, there are three parts that we, this is more from how you look at it, and I'll discuss a bit more detail what's actually in it. So we have the OIP website, whereas our ecosystem partner, the people who actually produce IP eventually to sell to customer, they're actually interacting with us through, we call IP registration system. We also interact with through an assessment system. So I'll discuss that in a second. Internally, we also develop our own IP, so these developers also have to go through the same system. The second system we have is an internal portal where our IP portfolio managers, people actually working with the IP manager, interact with the IP vendor to make sure that they register the IP and be able to manage the portfolio so that the customer know, say like for example, so tender cell, how many type, how many companies, what kind of level of quality they have. And then TSMC Online, where it's actual customer looking at all these IP, assessing the quality of these IP before they actually select them to put into the SoC. So there's a bunch of capability they can do there. So let's go to talk a little bit more about what's inside of these. So from the flow perspective, as a top part, the IP partner, when they start working with us, they certainly working with our ecosystem IP marketing first and say, hey, I have this IP. Then there's a number of customers interested in it, and they're going to put on SoC in the next node. I want to work with you to make sure that I pre-qualify this IP before the customer actually using it in their design. So that whole process, they are registered, eventually put it on the shuttle, get the chip back, measuring it, having a report, having assessment of the quality of it, eventually have a score. And then you put it on the website, and here's a customer actually can look at that, have a different question they might have with it, eventually put into the SoC and tape out. And there's also a process of cross-checking what's in the tape out versus what's actually originally in the IP submission so that we know there's consistency there. So this TSMC 9000 been around for about, I think, 8 years now. And it comprises a lot of these information in there. But if you remember, some of this we'll discuss that at the end because some of these items could be standardized. But I think it's a complete program where we actually have the set of IP development material, design collateral, training, tape out, review, information sharing. So this is the one we actually train the IP vendor to do. And then developing flow audit, where we actually go into each of the vendor site and actually do site audit. We actually have document audits and all the things that they submit to us about the IP. So there's a whole process, a whole environment to do that. Quality assessment, how we actually review that stuff, physical review, design kit, simulation review, a bunch of those there. We now also have, we call it a validation center, where actually the vendor actually can send the IP, the chip to us after they go through silicon. And we actually do the measurement for them. Okay, so I'll cover that in a minute. And then the IP master, which is a system to ensure consistency checking the customer tape out. So you can see the diagram on the bottom there, ecosystem IP come from the left. You go to this whole TSMC 9000 and then get it on TSMC Online, customer using it, and look at it, selecting it, eventually putting their design. And when they do tape out, there's a system to cross-check that with the original IP that's been passing all these on these tests. Okay. So this have a couple of levels. You see the hard IP, there's library, which is related to like standard cell memory, standard cells and I/O. And then the memory, which is embedded memory, non-volatile memory, a number of those, and then different IP specific as well, like USB, SerDes, all of that. So you can see each of those has a base level requirement, and also there's a IP specific requirement as well. So, and we also, in addition to the actual requirement at the end, we essentially produce some sort of we call quality indicator, where it has scoring, and it has also production record, number of tape out, and also number of wafer actually produced during the lifetime of this IP. So if you are an early adopter, a customer, you probably won't see a lot of these, but certainly people come later, they will be able to see like, okay, is this IP already being used by other customer, and what is the production records and number of wafer that produced by the IP. So hard IP, so that's actually, this is the one that's been around for the longest. So we actually now have 7 level of assessment now. So if you look at it, it's actually pretty simple to look at. There's a pre-silicon, that's below the dotted line, and a post-silicon above the dotted line there. So for pre-silicon, there's physical review. So these are pretty standard stuff, but we all have to make sure that it can be done, run on the customer, on the partner IP, DRC, LVS, ERC, antenna checks, and then most important thing also, we ensure that the IP, including the IP tag, which is including the vendor name, the IP names, and also any attribute of that IP. And this will stay with this IP forever. I mean, if the customer using this IP in the SoC design, send it to us for manufacturing, we'll be able to identify that through its whole lifetime. That's how we're counting number of tape out, counting number of wafer that produce that including this IP. So every single IP that from the IP vendor will have a unique IP tag. And then certainly DFM compliance, is this IP compliant to all DFM requirement? So LPC, lithography pattern check, CMP, DFM, LP, a bunch of those need to pass. And then before I go to silicon, there's a number of silicon assessment, QC, design kit review, and a design review. And after silicon bag, there will be tape out review, silicon report review, and then we have all these split lot and thing. And like the one in Circle, that's a new one that we just added last year, which is IP Validation Center. Right now, for a long time, we relied on the IP vendor to do the measurement themselves. So, but again, now we also have a choice where they actually can send their sample to us, and we do the measurement for them. The whole thing that you see a little bit later on is just consistency. You've got many ways to measure the same thing, and many equipment and stuff. How you know that the way they measure and the way we measure are the same, and the result are actually talking about the same thing. So that's one thing we added last year. And the last piece we already talked about, once the chip in production, we be able to measure that how many wafer that produce, that including that IP type. And then this is soft IP quality assessment. So a lot of talk earlier today is about high-level design, system-level design. So we do have a program that addresses soft IP. Right now we have 3 levels, the RTL code assessment. And right now we're using a partner tool called Trend Spyglass to do all of the checking for us. And then physical implementation assessment, and this is optional, mean that if you put this into physical design, what other thing that you can predict, right, from that soft IP, that will cover by that. And then certainly volume production, IP user tracking review. And this is what I mentioned earlier, the IP validation center. So this is a lab in Taiwan we set up. I think we can handle about 5 or 6 IP at any particular time. So essentially it could be 5 different IP. We also signed a deal with a testing lab, GRL, just I think a couple months ago. So now 3 of their lab also qualified to accept IP part from IP partner and do the actual testing for us. And all of them will produce the same type of results so we can actually review it together. And this is just example of, I mentioned earlier, if you do a testing yourself or setup, there are potentially a lot of different issues. From a setup, you can see in the first column there on the left, when you set up the test itself, there could be a number of software-related issues. And also when you identify failure weakness on the back end, there could be a potential discrepancy and differences the way how you approach testing. So essentially the center to ensure that there's consistency across the testing methodology and what we produce, what you actually want to measure. And then at the end, you got an IP validation report. So there's a standardized format that coming out. And then once it get online, this is what the customer can see. So you can search for the name of the IP, and you can compare them. So for example, in this case, we compare, I think, 3 different libraries, and you can see DFM compliance, 100%, 0% mean that probably they just started, right? They haven't completed this 100% here for this part. Physical review, pre-silicon assessment. So these are the 7 levels that I described earlier. So the customers see everything. 61%, 16% for all the IP that they're interested in. So they can compare and look at, and they also can, and you can see there's also a column in the middle. You might not be able to see the risk level, which is some IP actually missing something, and then it's probably still okay for tape out, but there's some risk associated with it. So we also listing them out. And also the last column there is actual volume production. So essentially all the information about the IP over its lifetime can be accessed here. And then, actually I just went through all of that there. What the benefit of all of this, after 13 years of doing this, this is the number of active IP that's still in the system, 9,800. And over time, these are the ones that we assess through TSMC 9000, about 11,000 IP. And typical IP review per month, about 150, 250. And in the last 13 years, we discovered 1,450 conditional failure and fatal failure, about 167. So that's good for customer, right? Because you want to discover all this early, fixing it up before actually you get used by the customer. And from a customer perspective, we also introduced a little bit more comprehensive way to look at the searching for IP, we call IP Center. So the customer can search and enter a lot of keywords for IP name, IP partner, technology, IP type. So they can actually more comprehensively look at all the IP available for this design. And this is just more detail. Actually, in this case, we also have a contact name there. So if that's the IP you're interested, you can click on the contact me, and actually it come up with a list of the contact at the IP partner. So you can contact them and then start a discussion how you want to use that IP in the design. So a standardization. Last year, actually, we take that IP tag specification and we actually publish on tsmc.com. And essentially now any IP vendor, whether they are part of TSMC IP Alliance or not, they actually can take this tag and this specification and then include that in their IP. And so that if they happen to be used by one of our customers, we can track that, right, over the lifetime. So then they can use their production number and come back and say, hey, we got this thing here, then they can prove it to their next customer that, the part already been through production, there's only wafer on it. So the tag here already been provided to the public in terms of trying to standardize that piece of it. Right. And next to the last slide here. This is one slide I presented earlier, TSMC 9000, all the pieces we're doing. So there are 2 items that we're looking at, figure a way to standardize it so that we can help the industry to figure out how to ensure some level of quality from the IP, whether it's a part of TSMC ecosystem or not, right? So IP development flow audit, there's a number of documents, a number of things that we developed over the year that can be supplied as a standardized document that IP provider can follow. And then IP quality assessment, how all of these view, all of these things are supposed to be organized so that all the information can be available to either the customer or to whoever actually qualify for the IP to look at. Certainly there's other area too, but we believe that those 2 that are probably the most useful for now. We actually start talking to a couple of standard organizations about this, and certainly that's something that welcome any input, anything that you guys might have, how to approach to do this. So my last slide here, we continue to invest very heavily into ecosystem quality. TSMC NiTile is our system of ensuring the quality for the IP for customer. And when we continue to work with a lot of IP ecosystem to make sure that we continue to provide these high quality IP to the customer. So that's my talk for today.